So if you're planning to move into Chemistry 30 or high school level chem, one thing that you should be very good at is dissociating and ionizing compounds and essentially getting into your net ionic equations, because this happens quite often in Chem 30, and so we want to be good at it. So to start off with, we're just reviewing what dissociation means, and if you do have a soluble ionic compound, then you can split it up into its ions if you take that solid and put it into water. So for instance, if you have sodium chloride, it will, if you put that in water, because it can dissolve, it will break up into sodium ions and chlorine ions. Now, whenever you're going to check, or if you don't know for sure if it's soluble, you want to check your solubility table. So for instance, if I was unsure about sodium chloride, I would come to the chlorine ion and then try and find sodium. Since sodium is not listed here, it would fall under most, and then we read the chart to the left, it says very soluble, meaning it will break apart in water. So when we do that, split it into the ions and you change your state to aqueous, because ions only exist in water. And then the next part with barium nitrate, it's the same idea. This one is soluble, we can double check it. Nitrate is up here. Barium would also fall under most because we don't see it here, so it would also be very soluble. If you are looking at your solubility chart, and when you do all of this, if it does come up as slightly soluble, then whatever compound you have as a solid, it just stays all together as a solid. You would write it exactly the same. Whatever you see on the left on your reactant side would be the same as your product side. So again, if you're not sure, check your solubility table. Now, when it comes to acids, you use a different term, but it's kind of showing the same thing. So for instance, if you have a strong acid like HBr, it will ionize. It forms an ion, but essentially we're still doing the same thing. We're making ions in solution. So that will break apart into H positive and Br negative. Now with acids though, only strong acids will ionize. Weak acids do not. So if you have a weak acid, like what we see here, acetic acid, if you put acetic acid into water, it's not going to break apart into its ions. It's just going to stay together. So if you're not sure, check your acids page in your data booklet. Anything above the gray line here is going to be a strong acid. Anything below that gray line, so all these other acids, are going to be weak. So if it's strong, break it apart. If it's weak, keep it together. Now we review that because that takes us into writing net ionic equations. And a lot of the times when you're looking at equations, there's a lot of things involved that don't actually do anything, and we want those to go away and see exactly what's reacting. So that is what a net ionic equation is. It shows you exactly the species that's participating in the reaction. So let's take a look at this first one. It says write a net ionic equation for the reaction of silver. So silver would just be Ag solid, right? Metals are always alone. We don't have a subscript, we don't have a charge, and we're going to react that with aqueous copper 2 nitrate. So copper 2 nitrate, we'd have copper, NO3, and then a little 2 here, and it's aqueous. So we start by writing out the full reaction, and hopefully we would know that this is a single replacement reaction, so your metals are swapping places. So now copper would be written by itself, again, as a metal. We want to write it as a solid. We don't add a charge, we don't have a subscript. And then silver will come together with nitrate, and both of those have a charge of -1, so we just need one of each, and this is AQ. Now, with our reactions, still do what you're used to. We still need to balance it. So to balance this out, we'll need a 2 in front of the silver nitrate so that we have 2 nitrate on each side, and that will also mean we need a 2 in front of the Ag. So this is just our complete balanced equation. Okay, so this is our first step. Our next step is to dissociate, break apart what we can. So this silver solid we can't do anything with, so you just write it down again. Copper nitrate in the aqueous state, we can break that into its ions. So when we break this apart, it will break into copper 2 positive, because that's the ion that was present, and the state would be aqueous. And then we're going to add on NO3 negative, and that state is also aqueous. But there are 2 of the NO3s, so I'm going to put a 2 in front. Then on the right hand side, my products, copper solid, can't do anything with, so just write it down again. And this is aqueous, so we can break up this ionic compound. And because of the 2 out front, that means there's 2 of each of the ions. So I'm going to have 2 silver ions and 2 nitrate ions. So this is our total ionic equation. It shows every single ion that's present in our solution. And now we get to our net ionic. And our net ionic, you need to cancel anything you see that's exactly the same on both sides. So in our case, it's that 2NO3. And now that is a spectator. It is there, but it's not participating. What is the actual reaction is that 2Ag solid plus your copper ion to give you copper solid plus 2Ag positive. And now we have our net ionic equation, and we can see exactly what's reacting. In Chem 30, you will do this over and over again. We want to be good at it. So as always, I hope you found this helpful. If you did, please subscribe. And if there's any other video I could do for you, just let me know. Thank you for watching.